Hey guys, in this video, we're going to do another follow-up question from SAT reading. And if you haven't checked it out already, definitely watch our first video on follow-up questions. We talk a little bit about the strategy for these questions and for the question that goes with them in a little bit more detail. So to sort of recap on follow-up questions, these are questions that look exactly like number 47. They're always worded in exactly this way: which choice provides the best evidence for the answer to the previous question? And they're a pretty common type of question on the SAT reading section. Usually they're about two per passage, and they're super, super, super useful because if you can answer the follow-up question correctly, you can almost always answer the previous question correctly because the follow-up question is basically just giving you the evidence that will tell you the answer to the previous question. So these are really great questions to practice because it's like a 2-for-1 deal. So let's do this. Let's get started. So to recap the follow-up question strategy, what we always do is read the first question, pick out some main idea from that question, and then pick the answer choice that mentions that main idea. Typically, only one of the answer choices in the follow-up question is even going to mention the main idea of the previous question. So you're going to be able to pick it out just by matching words more than half the time. Uh, Once you've picked out an answer for the follow-up question, you can read that quote really, really carefully and then use it to answer the initial question or the previous question. Okay, so let's give this one a try. The author notes that one reason Higgs theory gained acceptance was that it. So the main idea here is the reason that Higgs theory gained acceptance. That's going to be what we're looking for in all of these quotes. Let's take a look at lines 36 to 39. Push on a fundamental particle in an effort to increase its speed, and according to Higgs, you would feel the drag force as resistance. Justifiably, you would interpret the resistance as the particle's mass. So this is just a metaphor describing how the Higgs field works. So this doesn't tell us why scientists decided to accept the Higgs field. And we can eliminate answer choice A. Let's take a look at B, 43 to 45. Its interaction with the watery environment has the effect of endowing it with mass, so with particles submerged in the Higgs field. So again, this is just a metaphor being used to explain the Higgs field. It doesn't tell us anything about why the scientific community decided to accept it, so we can eliminate answer choice B. Our next choice is lines 55 to 63. But Higgs persevered, and his revised paper appeared later that year in another journal, and physicists who took the time to study the proposal gradually realized that his idea was a stroke of genius. So right off the bat, like look at this, physicists gradually realized that his idea was a stroke of genius. They're accepting the theory. So this is very likely our answer choice. Let's keep reading. One that allowed them to have their cake and eat it too. In Higgs' scheme, the fundamental equations can retain their pristine form because the dirty work of providing the particle's mass is relegated to the environment. So this very likely is our answer, but we're going to take a look at choice D just in case. The D is on line 78 to 83. On occasion, that happens in physics. Mathematical equations can sometimes tell such a convincing tale they can seemingly radiate reality so strongly that they become entrenched in the vernacular of working physicists even though there's no data to confirm them. So in this case, they're talking about physics in general. They're talking about how, theories are accepted very, very generally, not the Higgs theory specifically, and definitely not why it was accepted by the scientific community. So this choice is wrong. And our answer is C. So now that we know that C is the correct answer, we can use lines 55 to 63 to answer number 46. So again, we're looking for the reason that Higgs theory was accepted. So let's take a look at lines 55 to 63 one more time. So physicists accept it, they realize it's a stroke of genius, one that allows them to have their cake and eat it too. In Higgs' scheme, the fundamental equations retain their pristine form because the dirty work of providing the particle's mass is relegated to the environment. So the equations stay nice, and it's only the environment that they're worrying about. So they're having their cake and they're eating it too. They're having things kind of both ways. So let's look at these answer choices. A, it let scientists accept two conditions that had previously seemed irreconcilable. Accepting two conditions that had previously seemed irreconcilable, that's basically having your cake and eating it too. You're having things both ways. So let's take a look at B, C, and D and see why they're wrong. B introduced an innovative approach that could be applied to additional problems. There was nothing about additional problems mentioned in lines 55 to 63, so we can eliminate B. C answered a question that earlier scientists had not even raised. Again, this just isn't mentioned, answering a question that earlier scientists hadn't raised. So we can eliminate choice C, and D explain why two distinct phenomena were being misinterpreted as one phenomenon. So the idea that something has been misinterpreted, again, it's just not mentioned. So we can eliminate D, and A is our answer. That's all for this problem. Thanks for watching, guys. If you have any questions, you can leave them in the comments. And if you found this video useful, don't forget to like and subscribe, and I'll see you in the next video.